I am working with a dataset. It has 10 features, which we can think of as different characteristics or measurements, and one target variable what we're trying to predict. The dataset contains 10 features, labeled x sub 1 sub through x sub 10 sub, and a single target variable, y. Think of it as having 10 different pieces of information to help predict a single outcome. I am using the fregression function. It's part of the Sklearn library, a popular Python tool for machine learning tasks. This function helps select the most important features from my data. The fregression function gives me two important things: f-statistics and p-values. The f-statistic measures how much each feature helps explain variations in the target variable. The p-value tells me the probability of seeing this f-statistic if the feature had no effect on a target. This is the array of f-statistic values, one for each feature. A higher value generally suggests a stronger relationship with the target. Feature 0, for example, has a value of 10.5, while feature 7 has only 0.2. This is the significance level 1 set 0.05 or 5. It's a threshold. P-values below this threshold indicate a statistically significant relationship between a feature and the target. Based on the p-values and significance level, I'll determine which features are important enough to keep and which ones I can remove. Google style name lively. Here's the main goal: Google style break time 300 milliseconds. I am trying to select the best features for my regression model using the fregression technique, which helps me choose the most predictive features in my dataset. I have a dataset with 10 features, things I am measuring, and one target variable what I am trying to predict. Think of it like trying to predict house prices target based on size, location, number of rooms, etc. Features. This is a function from a library called Sklearn. It helps me figure out which features are most important for predicting the target. It does this using an f-test, which tests how much each feature explains the variation in the target variable. This array shows the f-statistic for each feature. The f-statistic measures how well each feature explains the variations in the target variable. A higher number means a potentially stronger relationship. This array shows the p-value for each feature. The p-value tells me the probability that I would see this f-statistic if there were no real relationship between the feature and the target. A low p-value, typically below 0.05, means the relationship is likely real. This is my threshold. If the p-value is less than 0.05, I reject the idea that there's no relationship, the null hypothesis, and conclude that there is a relationship. It's like setting a bar for how strong evidence needs to be before I believe something is true. I select any feature whose p-value is below 0.05. This means I've found enough evidence to suggest that these features are genuinely useful in predicting the target. These features have p-values above 0.05. That means I don't have strong enough evidence to say they affect the target. I can consider removing these for a simpler model. I am using the say as interpret as characters fregression say as function from Sklearn to pick a best features for a regression model. It's like choosing the most important ingredients for a recipe. Break time 300 milliseconds. I have 10 different characteristics say as interpret as characters or say as that might predict a single outcome say as interpret as character c say as. Think of it like trying to predict a house's price using features like size, location, number of bedrooms etc. Break time 300 milliseconds. This is a statistical test that helps me decide which features are truly useful for predicting a target. Break time 300 milliseconds. This function gives me two important results, the F statistic and the p-value for each feature. Break time 300 milliseconds. The F statistic measures how much each feature explains the variation in the target variable. A higher number suggests a stronger relationship. But we need more information. Break time 300 milliseconds. The p-value tells me the probability of getting these results if there's actually no relationship between a feature and the target. A small p-value, usually below 0.05, means it's unlikely that the relationship is by chance. Break time 300 milliseconds. I've set a threshold of 0.05. If the p-value is below this, I'll consider the relationship statistically significant. Break time 300 milliseconds. Time to test your understanding. Let's see if you can correctly identify which statements are true based on the provided data. Break time 300 milliseconds. Statement A is partially correct because features 0, 3 and 6 have p-values below 0.05. However, we should overlook other possibly significant features. Break time 300 milliseconds. This is a core concept in statistics. A p-value less than 0.05 indicates that the probability of observing the data if there were no relationship is less than 5, meaning it's likely there is a real relationship between the feature and the target. Break time 300 milliseconds. Correct. The p-values for these features are above 0.05, implying there is not enough evidence to suggest they have a strong relationship with the target variable. Break time 300 milliseconds. While a higher F statistic usually shows a stronger relationship, the p-value is the ultimate judge. A feature could have a high F statistic but a p-value above 0.05. making it statistically insignificant. Break time 300 milliseconds. I am using scikit-learn's sayAs interpret AS characters fregression sayAs function, a powerful tool for picking the most important features in a regression problem. Break time 300 milliseconds. It helps me find out which features are most strongly related to what I am trying to predict. Break time 300 milliseconds. Think of it like choosing the best ingredients for a recipe. You want to pick only the ones that make the dish delicious. Break time 300 milliseconds. I have a dataset with 10 different features X and a single thing I am trying to predict Y. Break time 300 milliseconds. For example, X could be things like age, income, and house size. And Y might be the price of a house. sayAs interpret AS characters fregression sayAs is a statistical test that helps me figure out which of my features is most important in predicting my target value. Break time 300 milliseconds. It does this by looking at how much the variance spread of each feature explains variance of the target. Break time 300 milliseconds. The function gives me two things, the F statistic and the p-value. Break time 300 milliseconds. The F statistic tells me how much variance in my target value each feature explains, while the p-value helps me decide if the association is statistically significant. Break time 300 milliseconds. This is a list of F statistic values for each of my 10 features. Break time 300 milliseconds. A higher F statistic suggests a stronger relationship with the target variable. This is a list of p-values. Break time 300 milliseconds. Each p-value corresponds to a feature and indicates the probability of observing the obtained F statistic if there was no real relationship between the feature and the target. Break time 300 milliseconds. A low p-value, typically below 0.05, suggests a statistically significant relationship. I set a significance level of 0.05. Break time 300 milliseconds. This means I only consider a feature important if its p-value is below 0.05. break time 300 milliseconds. Based on my p-values, I decide which features are important enough to keep and which ones to discard. Break time 300 milliseconds. I am essentially deciding what ingredients to keep in my recipe based on how much they contribute to the final product. Break time 300 milliseconds. These are possible answers to a multiple choice question based on the analysis of the f-statistics and p-values. Break time 300 milliseconds. We need to decide which statements are true based on our understanding of p-values and hypothesis testing. I am using scikit-learn's say-as interpret as characters fregression say-as function to help me pick the best features for a regression problem. I have data with 10 features x and one target variable y that I want to predict. The say-as interpret as characters fregression say-as function analyzes the linear relationship between each feature and the target. The function provides f-statistics measuring variance explained in p-values assessing statistical significance. These are f-statistics indicating the strength of relationship between each feature and the target. These are p-values reflecting the probability of observing the f-statistics if no relationship existed. I've set a significance threshold of 0.05 features with p-values below this are considered significant. I decide which features to keep based on whether their p-values are below my 0.05 threshold. These are options for evaluating the feature selection results based on p-values and f-statistics. I am using the say-as interpret as characters fregression say-as function from scikit-learn, a popular machine learning library in Python, to pick the most important features for my regression model. Break time 300 milliseconds. This is a key step in building a good predictive model because it helps me avoid unnecessary complexity and improve the model's accuracy. I have a dataset with 10 features, things I measure, and one target variable, the thing I want to predict. Break time 300 milliseconds. Think of it like trying to predict house price. Me features might be square footage, number of bedrooms, location, etc. And the target is the actual house price. In my dataset, X represents the 10 different features and Y represents the single target variable I am trying to predict. Break time 300 milliseconds. It's standard notation in statistics and machine learning. Say-as interpret as characters fregression say-as is a statistical test within scikit-learn. Break time 300 MSIT helps me determine which of my 10 features are most strongly related to my target variable. Break time 300 milliseconds. It works by performing a series of tests, one for each feature. The results of say-as interpret as characters fregression say-as are two things: the f-statistic and the p-value. Break time 300 milliseconds. The f-statistic measures how much variance in the target variable is explained by each feature. Break time 300 ms. The p-value tells me the probability of seeing a result like that just by random chance, assuming there's no actual relationship. I've set my significance level, often written as alpha, to 0.05 or 5. Break time 300 milliseconds. This means I am willing to accept a 5 chance of being wrong when I conclude that a feature is important. Based on the f-statistics and p-values, I need to decide which features to keep and which to throw away for my model. Break time 300 milliseconds. This is the core of feature selection. I am answering questions based on the results of my feature selection process. Break time 300 milliseconds. The questions are designed to test my understanding of statistical significance and how to interpret the f-statistic and p-values. I am given a significance level, and I am assessing which features are statistically significant. Break time 300 milliseconds. This means, given my data, are these features really related to the target variable or did it happen just by chance? I have a dataset with 10 features, things I am measuring, and one target variable, the thing I am trying to predict. I am using scikit-learn's fregression function. It helps me figure out which features are most important for predicting the target variable using a statistical test. The F-statistic measures how well each feature explains the variation in my target variable. A higher F-statistic suggests a stronger relationship. But we need to look at the p-value for statistical significance. I set my significance level alpha to 0.05. This means I am willing to accept a 5 chance of incorrectly concluding that a feature is important when it actually isn't. For each feature, I'll compare its p-value to my significance level 0.05. If the p-value is less than 0.05, I'll say the feature is statistically significant and likely related to the target variable. Based on the p-values, I decide which features to keep select and which to discard reject. I'll select features with p-values less than 0.05, these are statistically significant. I'll reject features with p-values greater than or equal to 0.05, these are not statistically significant. The X represents my 10 features and Y is my target variable. The p-value tells me the probability of seeing results like these if there's actually no relationship between the feature and the target variable. A low p-value below my significance level suggests a real relationship.